So here's number 29, and the question is, does this series diverge or converge? Does this series diverge or converge? Now, when you take the test, you can use whatever tools we've had up to that point. And I'm thinking of the tools I've had now in 11.2, and we've had geometric series. Does this look geometric? No. We've had telescoping, and you might sort of play around with that idea, is it telescoping, but it's not telescoping. And so then we had something else. We had the test for divergence. So that should be one of the first things you look for. Test for divergence. What does the test for divergence tell us? If it tells us this one does diverge. Here, from this problem, this is A sub n. And the test for divergence tells us if the limit as n approaches infinity of A sub n does not exist, or maybe it exists and it's not zero. If that limit is not zero, then the series diverges. This right here, the test for divergence, I'm going to put a box around it. Let me write test for divergence. And you just look at the A sub n part, and it does give the two things. If it's not zero, or if that limit does not exist, but if it does not exist, it's not zero. This is one of your best friends. So here, this problem, I want to find the limit as n approaches infinity of 2 plus n over 1 minus 2n. And I hope you can look at that and tell what the limit is. It's negative 1/2. What I'm looking at there, the degree of the top of the numerator is 1. The degree of the denominator is 1. So I'm looking then, since the degrees are the same, the limit is the leading coefficient over the leading coefficient. Well, that's a 1 in front of n, 1 over negative 2. So that's how I get this limit is negative 1/2. Now, is that 0? No, not 0. So it diverges. Yes.
Why would you, well, I saw someone else work the problem and they divided every term by n. Why would they do that?
Well, they're working it the formal way. Okay, so back when you learned last semester how to do this kind of limit, that was the formal way of showing it. But it boils down to the degrees being the same. Yes.
Can we use that limit test or the test for divergence for every series we run into? Can we trust it all the time?
If the limit of A sub n is not 0, you can trust it, and that's the answer. But if the limit of A sub n is 0, you got to try something else. You cannot just flip it. Yes?
So like that's one of the first things you should do, see if the limit is 0.
That's the first thing you should probably do. You could. That one would be kind of tough, wouldn't it?